Well, good evening, everyone. I'm Stephanie Burton. I'm the President of the Royal Society, and it's my honor today to be hosting this webinar, which is in fact a joint project between the Royal Society of South Africa and the Academy of Science of South Africa. We have had this shared program for a number of years now, and the purpose of it is in fact to showcase some of the leading research in both our organizations. I might say as I start this that we will certainly welcome any suggestions from members of the Royal Society of South Africa or RSSAf in terms of suggestions for future speakers. So please do feel free to contact me if you would like to make some suggestions. I also would like to welcome, before we start, some new members of the Royal Society, and just note that to be a member of the Royal Society, there is a process. It's available on the website, but it is, of course, for almost anyone who is interested in science and would like to be a member. So let me welcome Emeritus Professor George Vikatos, Dr. Martinez Dix, Ms. Chandri Tabele, Mr. Armin Rizai, Ms. Nadira Muller, Mr. Stefanos Dutoy, and Ms. Robin Craythorne, all of whom are new members to the Royal Society of South Africa. So welcome to them. This evening, we are taping or recording this presentation, and it will be available on the Royal Society website in due course. So please do feel free to notify those of your colleagues who are not necessarily here this evening, but that they can see it later. Our topic this evening is entitled 200 Years of the Cape Observatory. It will be presented by Dr. Ian Glass, who is the founder of the South African Astronomical Observatory Museum, which preserves items used in exploring the southern skies and has done so for more than 2 centuries. Dr. Glass is a member of the Royal Society of South Africa. He was born in Dublin in 1939, and he took his BA at Trinity College. His PhD is in physics, which he obtained from MIT on X-ray astronomy, and his interests subsequently have expanded to visual and infrared wavelengths from the X-ray. He is the author of a renowned textbook on infrared astronomy and 4 other books. He has motivated for over 2 decades to have the Observatory Museum declared a National Heritage Site. Sorry, the observatory, not the museum. And that has finally happened. It happened last year. So we are going to hear this evening from someone who really does have what you might call institutional knowledge or institutional history about something which is quite special and unique to South Africa, the Astronomical Observatory Museum. Dr. Glass, thank you very much for being prepared to give us this talk. And let me now invite you to share your screen and deliver your talk for us. Thank you very much.
What have I got? Excuse me for a moment.
It's okay. You should find the little icon at the bottom, right at the bottom of the screen, the share screen.
Yes. Just that my lecture disappeared. I just have to get it back again.
Okay.
Be a moment. Okay, here we go.
Thank you.
Are you seeing it nicely? I hope.
We are, yes.
Yeah. Well, yes. Thank you very much for the invitation to give this lecture. You probably all know the observatory because we would normally have met there in normal times. But it's really quite an interesting place. It's been going for just over 200 years, as we know, and has a very rich history. In fact, it was one of the very first institutions in South Africa of any kind of learned nature. So it's played quite an important part in South African science all the way through. So the Southern Hemisphere was very poorly known to the Northern Hemisphere until about 1600. And this map shows you what the classical people knew about the celestial sphere. It's a picture of Atlas holding up the globe of the cosmos. And you see the bottom part of it is uninhabited. It doesn't have any of the constellations marked. Above it, you see Pegasus, for example, and a constellation known as the Ship, which has been divided up in recent times. So it took until Halley and a few other people came southwards before we really got to know much about it. But the first important astronomer to come to Cape Town was Nicolas Louis de la Caille. He was from the Royal Academy of Sciences in Paris, and he visited Cape Town, as you see, 1751, 1753. Now, he actually got on very well with the governor of the time, and he was helped to build an observatory on the foreshore, just behind number 2 Strand Street, which would have been right on the beach at that stage. And if you see the picture down at the bottom, shows you Rogga Bay, as it was in those days, and the position of his observatory is marked. I'm pretty sure that the building in this picture is actually his observatory or a modified version of it, because it was painted a few years later. But he obtained positions of about 10,000 stars to an accuracy of a few seconds of arc. And he also worked out the distances to planets by means of trigonometry with other observers in the Northern Hemisphere. And while he was here, he defined and he named 13 constellations, which are still used today. His names are still used. And of course, Mons Mensa, Table Mountain, is the only constellation that's named after an object on the Earth. And while he was here, his second year was spent in measuring the shape of the Earth. He tried to measure the radius of the Earth, and he found that it was slightly peculiarly shaped, in the sense that the Earth was very slightly pear-shaped. And people were very dubious about this result, but it wasn't possible to prove he was wrong. And his measurements were, in fact, very, very careful. So to go a bit closer to the founding of the observatory, in England, in London, there was an outfit called the Board of Longitude that was founded in 1714. There'd been a terrible naval disaster in that year, and it was all due to very poor knowledge of where the ships actually were, and they ran into the Scilly Isles on the way back from an expedition. So the problem came down to finding time at sea, and when you can find the time using the stars, you can find the longitude. So they offered a set of prizes to anybody who could solve this problem. And for quite a while, for 40 or 50 years, various people tried. The most successful in the long term was the development of the marine chronometer. But that was, it was a very expensive instrument when it was finally developed. But, and so it wasn't very popular for quite a long time. But about the same time, various theoreticians developed what they call the method of lunars. And the idea there was to use the distance between the moon and various stars to work out what the time was, because obviously the moon was to some extent predictable in its motion. That was a very difficult problem. And so if you could observe that correctly and you had the right tables, then you could actually work out what the time was. So you can see what the person on board a ship had to do. He had to measure the distance of the moon from a bright star, such as Regulus or Sirius or one of the other bright ones. And he had to get the altitude of Regulus and the altitude of the moon using instruments on board the ship. Now, that's easy enough, but of course the Earth is a finite shape, so there was actually a parallax problem involved, and that's what made it difficult, because most ships' captains, were not mathematically inclined enough to solve the problem. But nevertheless, this was a practical method and a cheap one to find out what the time was, and then from that you could get your longitude. So the Royal Observatory was founded in 1820. And this man, who was the head of the Board of Longitude at the time, Davies Gilbert MP, he proposed an observatory at the Cape for the improvement of practical astronomy and navigation. Now, in the sort of intervening 70 years, the positions of stars could be determined much better because instrumentation had improved tremendously. And so instead of being a few arcseconds, you could get down to about 1 arcsecond of accuracy. And furthermore, the reason they chose the Cape was partly that it was very convenient to get to from England. It only took 3 months. But there were 2 people on the Board of Longitude who had actually some experience of the Cape. One of them was a famous botanist who was the head of the Royal Society. And the other one was a person who'd worked as a civil servant during the first British occupation at the Cape, and he in fact married a South African lady. So there was quite a lot of knowledge of the Cape and how good a site it would be. Anyway, things could move quite quickly in those days. So by the 20th of October, 1820, they were able to get the observatory legally proclaimed, and the Admiralty was assigned to look after it. And so within a few days, they'd appointed the first director. And obviously this was a put-up job because, these things normally take a lot of time. But the Reverend Fearon Fellows was a mathematician from the same generation as John Herschel and Babbage, the computer man. So he was a well-qualified person to undertake a new observational task. There were not many professional astronomers in those days, as you can imagine. It took about a year before Fellows arrived at the Cape, because of course 3 of the months were due to the sheer time it took to travel, but he also had to spend time getting his affairs in order and understanding what instruments he needed and how to use them and so on. So when he got here, he set up a temporary observatory in Kloof Street, and that building actually still exists. It was a private house. And while he was there, he had to find a suitable site for the observatory, and it needed to be visible from ships in Table Bay so they could send time signals to the ships. Another problem was that it had to be reasonably accessible. And of course, in those days, the roads were very poor. There was also a severe problem of dust because of, they didn't have tarred roads or anything like that. So in the end, they selected the site where the observatory now is, which was a kind of small hill. And in those days, it had an unobstructed view towards Table Bay. Fellows, we only have this silhouette of him. We don't have a proper picture of him. He managed to get the observatory built, but unfortunately, by the time it was finished, it was about 1828, he had actually succumbed to an illness because it was a very unhealthy site, unfortunately. It had a lot of swamps around. And so he had hardly got more than 2 or 3 years of use of the observatory before he died. So he didn't manage to achieve very much, in fact, in terms of astronomy during his short time here. But anyway, to go back to what the building was like, this shows you the plan of the building, which was made in London by John Rennie, who was an architect and engineer that worked a lot for the Navy. And so it was built more or less according to his plan. You see there were 2 large wings on each side, which were basically residences. suitable for gentlemen of the period. On the left observing room in this drawing was occupied by something called a mural circle. And that was a means of determining the declination of stars. That's there where they lie in the north-south direction. And it's more or less analogous to latitude in geographical maps. On the right observing room was a transit telescope. And that timed, that in conjunction with the clock, it worked out when a star transited from east to west. And that was what we call the right ascension. So those two coordinates define the positions of the stars. And the center part of the building wasn't actually built quite as shown there. So the building opened up like this. These instruments just had to be able to observe along the north-south line. So there was a slot right across the building from the north side right across to the south side across the roof. And so that way you could determine both declination and right ascension. And since that was the only thing the observatory was expected to do, you didn't need to look at the whole sky. These slots still exist, but they've been covered over by a thin wallboard, but they actually still exist inside the walls. You see in the center of this slot, one of the telescopes that was put there a bit later on. Now, Fallows, as I said, died rather prematurely. He was succeeded by this person, Thomas Henderson, who is a Scot, a lawyer by background, but a very good calculator and astronomer as well. And he actually hated every moment he spent at the Cape. He only stayed for a bit over a year, but he found the whole place too crude for his liking. And of course, there'd been a bit of a cutback during the building of the observatory. So there are a few things like toilets and fences and so on, roads lacking. So everything was very primitive. But he did nevertheless managed to do a lot of work, but he did something very important, which really put the observatory on the map eventually. And that was he verified Copernicus, because Copernicus produced this diagram that you see of the Earth and other planets going around the sun. But if what Copernicus had said was true, when you observed stars from two positions on the orbit of a planet, you should be able to detect a slight difference in angle. Now, people had tried very hard to do this, but they'd never succeeded. And he, in fact, made the first successful observations that showed what we call parallax. In other words, it gave you, using the Earth's orbit as a baseline and the angle that you measured, you were able to tell the distance of a star. And that's the first time it was possible to do that. Unfortunately for him, he sat on his results for quite a long time, and he was scooped, in terms of publication at least, by Bessel, working from Königsberg in Germany. But he certainly does deserve credit for being the first person to actually get a usable measurement. A purpose of the observatory was also to produce time signals for ships so that they could adjust their chronometers. That is, the ships that could afford to have them. They had to have two or three or four at least, because you could never be sure if one was going wrong. So if you had a few, you could usually tell which one was the one that was going wrong. But on the left, you see a time ball, and this was a kind of time signal that was used until about 1930. And at a certain time of day, this ball would be dropped so that ships' captains could adjust their watches and clocks accordingly. But Henderson had actually used a signal pistol. He had bought this pistol, which fired a flare at a certain time. So he had to go up with a stopwatch to the roof of the observatory, and at a certain time of day, or maybe in the evening, he fired the pistol, and the ship's captains could make use of the flash to set their chronometers. And the observatory time was kept by this particular clock that you see below, the Hardy regulator. A regulator is simply a very fancy grandfather clock, you could say, but it was very much more precise than the average clock. It had a very big minute hand, and it had reasonable size second hand and hour hands, and a very loud tick. because if you were observing with the transit circle, you had to be able to hear the tick and count seconds until you could actually write down the information. Well, Henderson, as I say, gave up and wrote some letters to the Admiralty saying that really conditions were just too awful, that they had no right subjecting astronomers to those sort of conditions. But anyway, Thomas McClure, who was a doctor by training, but also an amateur astronomer, became the third astronomer or director. And he was a much tougher character. And he soon made sure that the Admiralty forked out enough money to take care of things like toilets and roads and fences. And they didn't have to worry about cattle sticking their head through the window and stuff like that. So he stayed a long time, as you can see, for 37 years. And he, apart from obtaining positions of stars, which was their main task, he also did geodetic surveys. He was interested in the shape of the Earth, and they wanted to know what had gone wrong with Lacaille's observation 70 years before, 80 years before. Excuse me. Of course, McClure is very well known. I think his geodetic activities brought him in touch with lots of parts of the country. So, for example, McClure's Beacon on Table Mountain, Cape McClure down at Cape Point area, and another Cape McClure in Lake Malawi. And there's the town of McClure, which has now got an unpronounceable name. And there was a lunar crater named in his honor. While he was here, things were starting to move quite fast. He brought with him Thomas Bowler as an assistant and partly a personal servant, as far as I can make out. And so Bowler actually worked at the observatory for a year or so, but he got fired for being cheeky to Mrs. McClure. I've never managed to find out what exactly happened, whether he made a pass at her or just plain rude to her or what. But anyway, he left the observatory and had to make a living somehow. So he actually managed to become a drawing teacher and eventually became a very well-known artist. But these two little pictures at the top show you what the observatory looked like in 1834. And you see there was absolutely no vegetation on the observatory hill. It was just a sort of summer grazing ground, winter grazing ground, and it had to be beautified by the astronomers. The Admiralty refused to pay anything towards that. Another very interesting person that came during McClure's time at the Cape was Charles Piazzi Smith. And he was a young prodigy, and at the age of 15, he was appointed chief assistant at the observatory. He stayed for something like 10 years. But amongst the many things he did when he was here was take the very first photographs ever taken in South Africa. And the observatory was in fact the subject of some of them. And these are probably the first photographs of any observatory anywhere. You see that it had domes on top of it, but they were actually quite useless because they were on basically sitting on the ceiling of those rooms. And as anybody walked across the room, the whole thing would vibrate. So it was quite useless in terms of trying to use it to see things with the telescope. Another person that was around during McClure's time was William Herschel. William Herschel's father was the discoverer of the planet Uranus, and Herschel himself did a lot of very interesting things, but his main purpose in coming to South Africa was to survey the sky for what we call nebulae, which are cloud-like objects such as galaxies and star formation regions, as we know now. But he had the family in 1783, his father had built the telescope you see on the left, and they reconstructed it and prepared it to send to South Africa and set it up in Claremont, what is Claremont today, at the place where the Grove Primary School is now. There's a monument on the exact spot where the telescope stood. But the work he did with this telescope formed the main catalogue of nebulous objects for forever, so to speak. The oldest dome in the observatory that's actually still there is dated from 1848, and it runs on cannonballs. It was prefabricated in England and sent out, and it had a 7-inch telescope inside. And in the middle, you see something called an eyepiece micrometer that was used for measuring the separation of double stars. And double stars are very important because using the information you get from them, you can actually work out the masses of stars, which is really the only way we have of working out masses. Another thing the observatory was expected to do was to be a kind of bureau of standards for the Cape. And it was the repository of standard weights and measures. And in addition to the things you see here, we have a number of standard lengths. So the standard yard, which was a copy of the British yard in the Houses of Parliament, was kept at the observatory. We still have it. Maclear was expected to be a weatherman as well. And as you see, he wasn't terribly successful. He was supposed to predict good weather for the launch of the breakwater in Cape Town when they finally got around to making a harbor. But unfortunately, it was a disaster because it poured on the occasion. He also installed something called the Airy Transit Circle, which was a copy of a similar circle in Greenwich. The advantage of a transit circle was it combined the two instruments that I showed you before that formed the original instruments of the observatory with comparable accuracy. So this was in use until about 1950. Well, Maclear, you see here, he was buried, as was also Fallows, on the observatory grounds. Let's see. So he was succeeded by somebody called Stone, but he wasn't such an interesting person. So we go on to David Gill, who was probably the most important astronomer to have worked at the Cape. He started off as a watchmaker. He inherited a watchmaking business, but he wasn't very interested in watchmaking. He was really an astronomer by outlook. And as soon as his father died, he sold the business and moved full-time into astronomy. Well, he got the job here in 1879, and almost within 2 or 3 years, he was his sort of normal work was disturbed by the appearance of this great comet. This was one of the brightest comets ever known. It was so bright you could see it in the daytime. And what made it very interesting was that some amateur photographers actually photographed it. And what's more, they were able to see stars. So now on this picture, which is one of these amateur photographs, you see a lot of black spots, which are mildew, but you see white spots, which are actually images of stars around the comet. So this inspired Gill to try and do a little bit better, because of course, if you just take a picture of the sky with an ordinary camera, it gets blurred because the sky is moving with respect to the Earth. And so he decided to mount a camera on the side of a telescope that could be used to track the stars. So this was one of his very first photographs of the Great Comet of 1882. And of course, you see many, many stars in the background in this particular case. And he realized, of course, this was the ideal way to catalog stars and star positions. Up till that time, every star had to be observed one by one using transit circles or circles and mural circles. So if you could photograph them, then you could observe many stars at once. You had a permanent record and so on. And so that he decided to set up a special telescope to be able to do this. It had been done for the Northern Hemisphere. The Bonner Durchmusterung, it was called, had catalogued hundreds of thousands of stars in the north, but by this laborious one-by-one method. So he set up this telescope here, you see on the left, and he produced a catalogue of, there you see 454,000 stars. Now, of course, it's all very well to photograph the stars, but you have to measure their positions on the plates. And of course, you have to compare them to standard stars whose positions are accurately known by other means. So he was able to persuade a very well-known Dutch astronomer, Jacobus Kapteyn, to undertake this task. And Kapteyn had this motto, "Wijsheid is beter dan robijnen." That means wisdom is better than rubies, but Gill translated it as whiskey is better than red wine. So after he'd done that catalogue, his method was very attractive to other astronomers around the world. So a very large number of observatories got together and they decided to make something called the Carte du Ciel. And each observatory was given a certain zone of declination that was to be its speciality. And each observatory had a similar telescope of about the same focal length and with the same field. This is a picture taken, a 24-hour exposure, if you can believe it, of the Eta Carina Nebula, which was quite a tour de force for that time, given the sensitivity of plates. And to do a 24-hour exposure meant that you kept the plate in the telescope and just closed it off, during the daytime, so that it took probably 3 or 4 days, 3 or 4 nights to actually get a long enough exposure. So this Carte du Ciel was a sort of mixed bag because it used an awful lot of effort. On the other hand, it caused tremendous interest in the structure of our galaxy, and it had a very good long-term effect. So this gives you an idea of what it was like in the observatory 1897, sort of well on in Gill's regime. And you see these ladies dressed up in their best. They were what were called lady computers, whose job was to do a lot of the arithmetic that had to be done. And the person on the far right, that's this guy here, is Willem de Sitter. He was a postdoc who came from Groningen, but later in life he became extremely famous for having found a solution to Einstein's gravitational equations that indicated an expanding universe was a possibility. So this was part of the inspiration that led to the discovery of the expanding universe. And next to him, this prosperous looking guy is of course Gill. And there are several other quite well-known astronomers of the time in the picture. And it's quite interesting that at that stage, they didn't include the black workers. There were always 2 or 3 black workers doing the grounds. Later on, a few years later, they opened their minds a bit. The library of the observatory is an interesting reflection of the interests of the different astronomers who worked there. Usually the more active the astronomer, the more books they bought during that period. And Gill, of course, was one of the most extreme examples of an active astronomer, and his correspondence runs to tens of thousands of letters. But we have a lot of very interesting books, including some unique series of journals, such as the Royal Academy of Sciences of France from the 17th and 18th century. I don't think there are any other copies in South Africa. But we also have some very old books, and this book plate on the right, or rather crest, printer's crest, comes from 14, something like that. It's Ptolemy's Almagest. It's the first printed version of Ptolemy's work. But we have quite a lot of other quite interesting books. So Gill had always wanted to do what's called astrophysics, in other words, the why and wherefore of stars, and not just, the positions of them. So he had wanted a large telescope, but the Admiralty wouldn't pay for it. Wasn't in their interest, and nor could he persuade Rhodes to finance it, like some of the American philanthropists might have done. However, Frank McLean, an amateur astronomer from England, offered to pay for it. And so he finally got his telescope in 1897 or so, and he got Herbert Baker to design it. Herbert Baker designed quite a few of the famous colonial buildings. Now, next to the telescope, they built a laboratory because they wanted to be able to compare chemical substances on the Earth to what they could see coming in space from stars. And top left photograph shows what the lab looked like around 1900. The bottom left picture is how it was when I came. I brought infrared technology to the observatory, and it was necessary to set up a lab to do that. It was quite a complex technology involving cryogenics, electronics, optics, and everything else. So I needed laboratory space for that. Unfortunately, that room was available. But when we got a new technical building in 1987, that room became free and we turned it into a museum. So if you ever visit the observatory nowadays, you can look at our collection of very interesting small scientific instruments accumulated over the last couple of 100 years. Well, Gill left a number of buildings which still exist, and you see some pictures of them here. The one at the bottom right was the reversible transit circle, which was the most accurate way of determining star positions at the time, and probably one of the best of this kind that was ever built. The sort of peak of the observatory's reputation was around about this period, and towards the end of the Gill regime and a little bit afterwards. And they had some very good people involved. So the top left picture was taken when a group of scientists were on their way from England to Australia in 1914 to attend the British Association for the Advancement of Science. And they stopped off at the Cape. Of course, the whole thing had to be cut short because of the outbreak of the First World War. But it was visited by Eddington, for example. And in the observatory was Lunt, who was a spectroscopist who first discovered some of the elements in stars, silicon and europium, and Helm, who was a pioneer of stellar motions, of what we call stellar dynamics. And Huff was the director of the time. And you see this guy sitting on the floor. He was one of the so-called crewmen who were naval ratings employed from the west coast of Africa. And we always had a couple at the observatory during that time. And Willem de Sitter, the person I told you about, who was a leading theoretician later in life. Franklin Adams did the first all-sky survey, another wealthy amateur. Fout was a Dutch guy who was a pioneer of star distances using photographic methods. McLean, the person who donated that telescope, he discovered oxygen in stars. And Innes, he discovered Proxima Centauri, which is still the nearest star known. It's in orbit around Alpha Centauri, but anyway, he was, by then, he did work at the observatory in Cape Town, but later on he was the founding director of the Johannesburg Observatory. So this is the aerial view of the observatory at the time that Gill left, and it stayed more or less the same for about the next 20 years. We can tell it's before 1930 because of certain buildings that don't exist yet. So what else did Gill do? He was very concerned about the scale of the universe, and the most important single thing to know is the distance between the Earth and the Sun, because everything else is based on that through the signs of parallax of nearby stars. He made geodetic surveys. And so some of the early geodetic surveys of the African subcontinent were done by him. He also surveyed the border between South Africa and Southwest Africa. He was trusted by both governments to actually do this work. Of course, nowadays, when minerals are involved, they're very much more cautious. And he was, of course, a very social person. Amongst other things, he was involved with the Owl Club and the Royal Cape Golf Club. So succeeding Gill were these Her Majesty's astronomers, the last three. Spencer Jones eventually became Astronomer Royal in England. Jackson didn't do anything very particular. Stoy was the last of the directors of the Royal Observatory and tried to encourage it to survive into the present century. However, what this slide is about is to tell you that traditional astronomy kind of came to an end somewhere in the early part of the 20th century. because it became obvious that we were living in the outer part of a barred spiral galaxy. Slowly became more and more obvious, and that the Milky Way is just one of many galaxies. All this sort of stuff was unknown before 1900. So the expansion of the universe was discovered around about 1925. And of course, the consequences of these discoveries about nature of our galaxy and the discovery of other galaxies sort of defined mainstream astronomy for most of the 20th century. Of course, we see the Milky Way because we're actually embedded in it. We don't see its spiral nature, but gradually, as new space-based satellites and so on have come into use, we're starting to be able to plot more and more of the detail of our own Milky Way. But just to give you some ideas of what was going on during the 20th century, there was a big expedition to Calvinia for an eclipse in 1940. Those upper two pictures are like that. Finally, we got a 1 meter telescope, bigger telescope than any of the other ones. That particular telescope is now in Sutherland. And the kinesiodolite was used to track some of the early Earth satellites. We were an important station for finding out where satellites had actually gone, because in the early days, they weren't too sure what happened to them after they got launched. And we got a 0.5 meter reflecting telescope in Cape Town. So in the next little bit, a lot of things were happening. Cosmic radio sources were discovered, and that was mostly around the time of the Second World War. Of course, pulsars, you all know the stories of the discovery of the pulsar, I'm sure, and quasars, quasi-stellar radio sources. And then, of course, space probes and X-rays were discovered coming from space. Infrared astronomy became practical. And gamma rays were discovered from space. And then, of course, the Space Telescope was erected, which gave us much more detailed view of objects in space. So a lot of new things were happening, and it was very difficult for an old-fashioned observatory like the Royal Observatory to compete. And of course, faint objects meant that you needed to have large telescopes to study them. However, during that period, the observatory had one very special person called Alan Cousins, and he made his lifetime in determining precision photometry. And a lot of his work is very fundamental to distance scales, and he became probably the best known astronomer in the latter part of the 20th century at the observatory in Cape Town. He also discovered a whole class of variable stars. So the problems, what were the problems? Well, sorry, let's go back. First of all, there was a general decline of interest in old-style astronomy. And of course, the funding was coming from the UK, and the astronomical community, who were becoming not so much Navy-controlled as academic-controlled, had lost interest in that type of astronomy. So there was a need for large reflectors to stay competitive. So we managed to get a 40-inch or 1 meter telescope in 1964, but that was fairly small potatoes even by then. But then a great blow was that the UK decided to share a 150-inch telescope with Australia. So it's partly for political reasons, because really the climate in Australia is not as good as the climate at the Cape. So the city lights and air pollution problems became more and more intense in Cape Town. So that sort of had led to already, people realized it couldn't go on like this. So they started searching for new sites in the 1960s. And that's, of course, so the last decade of the Royal Observatory, from 1960 to 1970, well, that saw the 150th anniversary. And as I say, in 1964, we got that 1 meter telescope. Stoy was the last director. David Evans was a very interesting scientist. I won't go into his work, but he was probably, apart from Stoy, the mainspring and Cousins. So both those decided around about 1968 they'd had enough, and they both quit the observatory, found jobs elsewhere. So that left George Harding, who was sent out, basically the administrator from England, whose job was to run the observatory. But it was round about that time that Sutherland came into the picture, and George Harding had a lot to do with getting Sutherland going. So he deserves quite a lot of praise for that. So that was what happened was there was the choice of Sutherland as a new place to have a station. Now this is before the British, before SAAO was founded. But the point was that he was free of light and air pollution, and the atmosphere can be very steady there at times. So the CSIR, South Africa, made an agreement with the Science Research Council in 1970 that the old observatories would all be merged and form a new observatory with a station at Sutherland. So in 30th of December 1971, the Royal Observatory ceased to be a purely British institution and became about 2/3 South African financed. And that carried on until middle 1980s. So in the meantime, the whole of Sutherland was built up. And of course, most of the observing was transferred from Cape Town to Sutherland. So the old observatory became the headquarters of SAAO, and the telescopes have gradually become less and less used, and they're starting to become very decrepit, I'm sorry to say. So the new observatory was formed at Sutherland, and the first 4 domes you see there, the 3 ones which were actual domes were erected around in time for the opening 1972 or 3. And Sir Richard Woolley, who had been Astronomer Royal and had some South African connections, became the first director for 5 years. On the right, you see Michael Feast. He became the subsequent director, and he, in many ways, was the person who established the scientific reputation of the new observatory. So he was director until 1992, and he just died a couple of years ago. So apart from those 3 original telescopes, this telescope was brought down from Pretoria. It's quite an old telescope, but quite a large one, so it was really worth having. It was finished in 1938, but optically ready in 1948, and it was constructed in England. Well, I'm going to tell you just a few of the projects it did. I'm sorry, they're mostly my projects. So, Patricia, who I see is one of the people watching, was involved in this one. This was a map we made of the center of our galaxy. It's probably the best infrared map made at that time. Of course, you cannot see the center of our galaxy in ordinary light, but in infrared, which can penetrate dust, you can actually form a very accurate picture of the center of the galaxy. And of course, part of astronomy has been looking at this area more and more accurately. Another thing that caused quite a sensation when it happened, I built an infrared camera, platinum silicide infrared camera, and a number of people, in fact, you see here a Japanese colleague doing the observing. We observed the collision of various parts of a comet Schumacher-Levy with Jupiter in 1994. And we were the first people to do this successfully, although a few other observatories managed to latch on. But you actually see the little, let me see if I can, just here you see the beginning of the collision, and gradually it gets brighter and brighter, and then it fades away. So that was one of the many fragments of this comet colliding with the atmosphere of Jupiter. So we got, in the year 2000, the Japanese installed a very interesting telescope here. That became one of the most successful survey telescopes in the infrared. And it's been used quite a lot by South African astronomers since. So Sutherland today is quite a city of telescopes, or a village of telescopes, you can say. There are more than 20 telescopes of various types and sizes. SALT, of course, is the very famous one. It's the largest single dish telescope in the Southern Hemisphere, possibly one of the largest in the world. Then we have the one that's in the background. Let's see if I can even figure out which one it is. It's this telescope. No, is it? Sorry, it's here. Sorry, it's just in the distance, so it doesn't look very big. Then the 1.9 meter telescope is in this funny shape, this turret shape. And then we have the infrared survey telescopes and several other medium size. But what's become quite important nowadays are telescopes that monitor the sky in various ways. And of course, computing has helped handle the data that arises because of this. So they look for variations for planets around other stars, and there are many different international partners involved. And of course, there are other installations there. There's a gravity meter and air glow monitors and so on. So it's become quite a sort of scientific village. The South African Large Telescope is probably one of the most exciting ones we've had. So it offered the maximum, this particular design offered the maximum collecting area for the minimum cost, though a certain, to some extent, an expense of versatility. But it has 91 hexagonal mirrors to form a spherical surface, 11 by 10 meters. So the main structure is stationary during an observation, and the reflection of stars are actually tracked using a special beam across the front end of the telescope. So it's constructed around 2000 to 2005, and was not had some problems at first, but it's very satisfactory now in producing vast numbers of research papers. And it's actually partly an international project. So South Africa has about a third of the observing time, and the rest is owned by different countries. And of course, everybody gets time in proportion to how much they pay. So this was an era of major change in astronomy. One of the most important things has been an improvement of detectors, because the early detectors were human eyes, and then of course, photographic plates. Now, the point is they have a quantum efficiency of a few percent. Now, quantum efficiency means that when a photon of light arrives, does it get detected or not? And most of the early detectors were very inefficient from this point of view. But now with CCDs, charge-coupled devices, such as something like what you have in digital cameras, we're approaching 100% efficiency. So that means that sort of a small telescope now can do what a big telescope could do before, although of course there's always reasons for going to bigger and fainter objects, bigger telescopes, fainter objects. Of course, online computing, high-power computers have made a big difference. And of course, we can monitor the whole sky for things that change with time, which is a very important part of a sort of new part of phase space to be investigated. And we also can look at many more wavelengths, you know, outside the visible band from satellites and from radio observatories and so on. And international collaborations are very important. And of course, where one astronomer could write a paper in the old days, it's very rare now for that to happen. Most papers are written by large groups of astronomers in collaborations. So just to finish off with, more or less, to give you an idea of the observatory and its size, the last annual report that we have talks about 176 staff and affiliates. And you can see there are scientists, about 41, technical staff, which is a huge section compared to what it used to be like, 37. IT, for example, has 12 people. And then support of one kind or another, like all the maids and gardeners and maintenance people, 42. And then we have outreach, it's become an important part of our work. And total refereed publications, 262. And so we are, just to explain, we are part of the National Research Foundation, which I'm sure all of you have had your contacts with, and that's part of the Department of Science and Technology. So I think that's really all I wanted to say. This is just a recent aerial picture of Sutherland showing you the telescopes from a different point of view. So I'd be very happy to answer any questions that people might have. I'll stop sharing now.
Dr. Glass, thank you. What an amazing presentation. You have taken us right through the most amazing history from what I was fascinated to hear, that there was once a board of longitude, to what we have now, which is, of course, as you say, the National Astronomy facilities, the SKA, the SALT, and so on. And really, in between, you've covered a wealth of history, which has been absolutely fascinating, especially for those of us who are not necessarily informed about history. But not only did you tell us about the history of traditional astronomy, but also your photographs and your examples and your stories covered the science and the social and political aspects of life through 200 years in this country. And I salute you. I think it was the most fascinating talk. So thank you very much indeed. I see we have a few questions. So let me just indicate to those who are going to ask questions, there is the opportunity to put your questions in the chat box, but you can also raise your hand, and that you do by going to the bottom of the screen, and where there is a little icon which says reactions, you can raise your hand there. So let us take those questions. I did see that there was a hand up a moment ago, and it seems not to be up anymore. But there is a question in the chat box, so let me just ask you this one. I don't know if you can see it, Dr. Glass. There's a question about the development of South Africa surveying cadastre centered on Cape Town, and difficult to read this. If you can see it. So with the eventual demise of the Hubble and the focus on non-visible observation, do we risk losing optical magic? That's a lovely term, of the visible spectrum. Would you like to address that question?
Well, yes, I tend to feel that a lot of the excitement has moved to the SKA, actually, because that's really going to be a world beater, and is already, you know, doing pretty well in the shape of the Meerkat telescope. But in a way, it's a more unique type of installation than our optical observatories. Although, I mean, there's still an awful lot to be discovered. But I must admit, if I was going in for astronomy, you know, again, I probably would go more towards radio telescopes and the radio side of the spectrum, or even some satellite work. Because, of course, you know, there's a new James Webb Space Telescope due to go up fairly soon, and that's going to be an infrared specialized telescope. So I do, this is just a personal feeling though, that I do feel that those things are offering perhaps more exciting new stuff than our existing telescopes.
Sorry, Dr. Glass, it was myself who asked the question. So
Please
what I was
go
getting
ahead.
at, yes, what I was getting at was, you know, part of the magic and the attraction of this to younger generations was the optical beauty of Hubble as an example. And, you know, when we lose the visible spectrum component of it, do you think that we'll be able to regain the magic in sort of false color images based on the electromagnetic spectrum outside of the visible?
That's an aesthetic question, really.
Yes,
I do think that yes, I think that the enormous well, the detailed color pictures of distant galaxies are absolutely amazing, and also, of course, you know, the famous pillars of star creation and so on. That's probably the most famous picture that's come out of Hubble. I think we'll have a lot more things, you know, really exciting things coming out of that kind. So yes, I mean, you know, a lot of people go into astronomy from the wonder of looking at things just with small telescopes as children, and of course, that sort of sense of wonder has stayed on. So I think there's still going to be plenty of that. I mean, false color images, yeah, I think they're very valuable as well.
Thank you.
Thank you. Dr. Glass, have you written this up in a document? Is there a history written up?
Yes, I have a paperback history of the observatory. In fact, which I wrote a couple of years ago. It's more about the Royal Observatory period. It doesn't really bring us properly into the 20th century, but I'm hoping that we were intending to produce something for the 200th anniversary, but of course, you know, the COVID sort of really cut back our activities quite a lot. But I still think we might come out and produce a new history. I mean, even, you know, what's happened, I've given you only a very brief look at SAAO because I've been retired for most of the last 20 years when Sutherland has been, especially the SALT telescope, has been at its peak. But I do think I could perhaps have said more about that side of things.
Can I invite anybody else who would like to make a comment or ask a question? Rusty Hendricks, I see you wrote a comment in the chat and I see your camera on. Would you like to make a comment?
No, just thank you very much for a fascinating talk. I never knew the observatory had such a rich and interesting history. And I love history, and I must say I was very well entertained by Dr. Glass. Thank you very much.
Thank you.
Thank you.
Well, ladies and gentlemen, I think if there are no other questions or comments, you timed it beautifully, Dr. Glass. This is exactly the moment when the webinar is due to finish. So let me again say thank you very much for a fascinating talk, and one that really does underline, I think, some of the principles of the Royal Society, the value for appreciating the history of science and the importance of science, and the importance of making sure that our public also hear and see the fascination of sciences such as astronomy. So thank you again, Dr. Glass, and colleagues and friends who are here. A number of them I see are old colleagues of mine, and it's delightful to see you here. Thank you very much for attending. And we look forward to the next one. You will hear about it, of course, through the Royal Society messaging. So let me just say thank you again. Welcome. Thank you very much for your presentation, Dr. Glass, and let all of you stay well and have a good evening for the rest. Thank you.
Thank you very much, Stephanie. Very kind of you to say.
Thank you.
All right.
Goodbye.
Okay, bye-bye, everybody.
Stay well.
Thank you.